In this video, we are going to learn how to use work kinetic energy theorem to solve problems that involves friction on an inclined plane. The question says, a ski jumper glides down 30.0 degree slope for 24.4 meter before taking off from a negligibly short horizontal ramp. If the jumper's takeoff speed is 13.7 meter per second, what is the coefficient of kinetic friction between the skis and the slope? Let us first sketch the problem. So let this be the slope, and slope is making an angle of 30 degree with the horizontal, and let h be the height of the slope. The person is skiing from here, and the length of the slope is 24.4 meter. This is the total length. Let us call that as L, 24.4 meter. When we are solving problems like this, problems that involve friction, we need to first draw a free body diagram. So let's draw a free body diagram for the question. The first force we will draw for the skier is the force due to gravity, which is acting vertically down, Fg. Then we have the normal force, which will be along the y-axis, F normal, and the force of friction, which will go opposite to displacement. After we draw them, we will split gravity into its component. Since gravity neither lies on the x-axis nor the y-axis, we have to split that into component, Fgy and Fgx. Fgx will go along the slope of the incline, and Fgy will be along the y-axis. After we draw the free body diagram, we can write the expression for all the forces over here. We know for an inclined plane, Fgx is mg sine theta. Fgy will be mg cosine theta. Now in normal vectors, x component of vector is generally cosine theta, but on the inclined plane it is opposite. So x component of a vector on the inclined plane, we take it with sine theta. That's why Fgx will be mg sine theta. Mg because the force due to gravity is m into g. So Fgx will be mg sine theta. Fgy will be mg cosine theta. Now, what is the expression for the force of friction? The force of friction is mu times Fn, where mu is the coefficient of friction and Fn is the normal force. If we look at the diagram, the normal force is equal in magnitude to Fgy. So we can write the force of friction as mu Fgy, which is mg cosine theta. The question wants me to find what is the coefficient of kinetic friction between the ski and the slope. To do this, I'm going to use work kinetic energy theorem. Now, the work done by the force of gravity at the top of the slope, that is the potential energy of the skier on the top of the slope, would be equal to its kinetic energy at the bottom if there was no friction. But when friction is involved, some of this work is done by the force of friction against the motion. So your total work done, my total work done will be work done due to gravity plus work done by the force of friction. Work done due to gravity is mgh, and work done by the force of friction will be negative force of friction times the distance it covers. So the distance of the slope, which is the length of the slope, we took it as L, so I will write that as L. Negative because friction acts opposite to the displacement. So we can finally write the total work done will be equal to mgh minus force of friction times L. Now this work done will be equal to the change in kinetic energy of the system, which is my work kinetic energy theorem. Work kinetic energy theorem says that work done is equal to the change in kinetic energy of the system. So I'm going to write this work done as the change in kinetic energy delta K, mgh minus F. Change in kinetic energy is final kinetic energy minus initial. Force of friction we can write as mu mg cosine theta into L. Now initial kinetic energy will be 0 because here at the top the skier is at rest. And then he starts to move down the slope. And when he take off, his speed is 13.7 meter per second. So I get my final kinetic energy as half mv squared, which is mgh minus mu mg, mu mg cosine theta L. So this mu is my coefficient of kinetic friction, which is what we need to calculate. Now let's cancel off m here because it's the same. And now we have to rearrange the terms to write in terms of mu. Now you can rearrange the terms or you can use shift solve here directly to get the value of mu. I'm going to rearrange them and then let's see what do we get the expression for mu as. This becomes v squared by 2 equals gh minus mu k g L cosine theta. Then we solve. I will move mu over here, the term with mu over here, and the term with v on the other side. And when we do that, the minus sign for mu k will become plus sign for v over here will become minus. So we get mu k g L cosine theta equals gh minus v squared by 2. Now, since I want to find the coefficient of kinetic friction, I'm going to divide by the rest of the term over here to leave mu k alone. So rearranging, we write mu k equals gh minus v squared by 2 divided by gl cosine theta. Now what is h? The height of the slope is not given to us. We just know the length of the ramp, not the height. The height of the slope we can find using trigonometry. I know the angle. I know the length of the ramp, which is my hypotenuse. So I can find the height using trigonometric values. We know the height is opposite to the angle theta. And the trigonometric rule we use for opposite side is sine theta. So I can write for this one as sine theta equals opposite over hypotenuse. So my opposite side is the height h, and hypotenuse is the length of the ramp, which is L. So I can get my height h as L sine theta. This I will substitute here in my final expression. So we can write the final expression as mu k equals GL sine theta minus V squared by 2 over GL cosine theta. Now substitute the value. G is 9.81, L is 24.4, sine 30 minus V is 13.7 squared by 2 divided by G is 9.81, L again 24.4, cosine 30. And when you solve this, you can get your answer for mu as 0.123.